Hi guys, this is James Hart with 2.1, Find Square Roots and Compare Real Numbers. This could otherwise be known as sets of numbers. Now I'm just going to introduce you to the different symbols that represent the different sets of numbers. And this first set right here is all real numbers. And this looks like an R. The next set is terminating or repeating decimals, and this is just a Q with a line down the middle. Then the next set is positive and negative whole numbers, and this just looks like a Z with another line. Then the fourth set is positive whole numbers, which is just an N with another line going down the middle. Then the whole number set, the symbol is just pretty much a W with another line. That's easy to remember because whole starts with a W, so just remember that. And then irrational numbers is just pretty much an I. And also remember that because irrational numbers. And then an irrational number is a number that cannot be written as a quotient of two integers. Irrational numbers cannot be a repeating nor terminating decimal. All that means is that the numbers can't repeat. It can't be 3.444 and then so on. It can't be that because then it's a pattern and it's repeating. An example of an irrational number is pi. Pi is 3.14159265535. There's no repeating throughout this. So this is an irrational number, and it goes on forever. It doesn't just stop right there. Just goes on forever and ever. Now, this is just a chart explaining real numbers, and hopefully you get a better understanding of it by this. And, this just shows that whole numbers are a part of integers, and integers are a part of rational numbers. Now, irrational numbers and rational numbers one number can't be a rational number and an irrational number. It has to be one or the other. But both rational and irrational numbers are all part of real numbers. Now here's an example going off of what you just learned right here. Just remember all of this stuff. And then tell whether each of the following numbers is a real number, a rational number, an irrational number, an integer, or a whole number. These are all just our sets of numbers that we introduced to you back in the beginning. Alright, so we're going to start off with the square root of 100. Hopefully you all know the square root of 100 is 10. Now, the square root of 81 is equal to 9, but if you pay attention to this negative sign outside, you have to bring it over and make 9 negative. Just remember that. Pay attention to the signs out there. Now, 24, the square root of 24 is tricky. The square root of 24 is 4.8989799486. Now think about which sets all of these numbers and square roots are, and try to come up with, for each square root, think of what group they're in, and remember which groups repeat and which ones don't, and which ones terminate and which ones don't. Now I'm going to show you the answers, so have the answers in your head and then try to check them. Is the square root of 24 a real number? Yes. Is it a rational number? No. Is it an irrational number? Yes. It's an irrational number because it just has random numbers going on and on. Is it an integer? No. A whole number? No, obviously it's not a whole number because all of this. And then the square root of 100, is it a real number? Yes. Is it a rational number? Yes. Irrational number? No. An integer? Yes. A whole number? Yes. Now the square root of 81, is it a real number? Yes. A rational number? Yes. Irrational number? No. Is it an integer? Yes. And is it a whole number? No. You might think, since the square root of 81 right here, you might think it's a whole number, but it's really not because it's negative. You just gotta remember the negative. Now this is just showing you a little bit of graphing, and you are gonna get problems like this, where it's asking you to list from least to greatest, and that could be tricky for some people, but one of the things that really helps is graphing them, and then you could tell in what order they go. So you have your number line right here, and then what you have to do is you find the lowest number. Well, first off, you have to find the square roots for all of those numbers up here. So the square root of 9 is equal to 3. The square root of 13 is equal to 3.61. And then the square root of 5, but remember, pay attention to that negative sign, is equal to negative 2.24. Now that you have all of those numbers, you just have to plot them. And we all know 4 over 3 is 1 1/3. So now you just have to plot negative 2.5 out of all of these numbers. Well, actually, here, I'll just list the numbers. I'm just writing them as they're listed up there, but in their normal forms. And then 3.61, negative 2.5, and then 3. So now that you have all of your numbers, not without like square roots and everything, you take negative 2.5 because you could tell that's the lowest number, and then you plot it right here. What's the closest number to negative 2.5? Negative 2.24. So that goes right there. Then the next number is 1 1/3. So you plot that right there. The next number is the square root of 9, which is 3, so you plot it at 3. And then the square root of 13 is 3.61, so you plot it there. And now it just goes in order from least to greatest. Okay, so now that you guys hopefully understand a little bit about graphing and finding the order from least to greatest, now we have a small word problem for you. And the area of a square painting is 3,600 square inches. Find the side length of the painting. Now, hopefully everyone knows how to find the area, and you have to multiply one side length. Well, for a square, every side length will be the same. So you have to multiply one side length by the other. In this case, since now we know square roots, we could just do the square root 3,600, and if you know the square root of 36 is 6, so 36 is 6, so if you remember that for this will be easy. You just have to add the 0, so square root is 60, so one side length is 60 square inches, and then you could test it, do 60 multiplied by 60, and it checks out. And then, so you just have to remember, with finding area, it's really easy. You just have to know what times itself equals the entire area. It's really easy, and that's just a small word problem. And hopefully you learned a little bit about sets of numbers, and it wasn't too hard.